right, there we've got a vector 2 that we are going to check question paper. All right, so that was actually 12 marks on everything. Did not put the marks there, or the person that sent this question did not put everything. Well, it's fine. Anyways, but this is a 12 mark question with everything on this question because it was section B, paper 2. From our WhatsApp group platform. So make sure that you join the WhatsApp group so that you'll be able to send your questions. We revise the questions together as a family based on African motives. So without wasting much time, let me quickly rush through the question that I'm having here. The first part, we are given vector G and vector H. Express G plus 2H in the form XY. So this is the format of a vector that we are given a column way. So this is the column form that you are given. So in this form, it's a column vector. All right. So we have the vector G, we have H, and we are given an expression to use in this explanation, which is G plus 2H. So you simply need to substitute into the formula. So vector G plus 2H will be equal to, we have vector G as a column vector minus 5, 2, plus the 2 representing the scalar. So this 2 is a scalar, which is going to multiply everything that we have in vector H. So this is H, and our H is 3, 4. So we're going to multiply. So take note there, the scalar multiplies everything that you are given into the given vector. This one, you're going to multiply everything inside by that 2. So meaning to say the first vector is going to remain as it is, but the second one is going to be multiplied by 2. So it's 2 times 3, which is 6, 2 times 4, which is 8 in this case. Then from there, you can add the corresponding elements. Whenever you're dealing with vectors, you combine corresponding elements. So meaning to say 5 is going to correspond with negative 6. So if we add minus 5 plus 6, this is going to give us a 1. So meaning to say I've got a 1 here. Then 2 plus 8, this will be a 10. So we have the equivalent of G plus 2H. That was our question. 2 marks for that. All right, so that's it. Let's check the B part. On the B part, we are given a diagram, which is a parallelogram. In this case, we are given that this is OABC is a parallelogram in which OA is 4P. So from O to A, that's 4P in this case. So this is 4 vector P. And OC, it's 5 vector Q. So this is 5 vector Q. The moment you are given that it's a parallelogram, that's why it's referred to as a property vector. A property vector meaning to say you are dealing with the properties of a shape that you are given. And the shape that you have here in this case is the parallelogram. What are the properties that you know on a parallelogram? You know that opposite sides are parallel and equal, not just parallel, but they will be parallel and equal in this case. So if this is the concept of a parallelogram, then it means these opposite sides will be parallel and equal. That is from O to C, which is this direction, O to C, which is 5Q, is going to be the same as from A to B. So this one, I'm just going to present it this way. From A to B, we are going to have 5Q again. We are not even answering any question. We are just filling in our diagram from the properties of the shape that you are given. The same thing applies to OA. The direction must maintain, or the arrow is facing this way. So your arrow from C to B must face this direction. The same way, this direction, from C to B or to A. So this is going to be 4P because we know that these two lines are parallel and at the same time they're equal. So this is the first thing that you're supposed to take note. All right, then we move on. We are given a certain statement that Q is a point on AC. So there's a point X is a point on AC such that AX as to XC is 2S to 3. So we are given the ratio of 2S to 3 in this case. So meaning to say AX is 2 parts in this case from A to X. Then from X to C is 3 parts. From X to C is 3 parts like this. This one is just a ratio to tell you how these points are related on this line. The line that we are referring to at the end is going to be the line AC, which is going to carry 5 parts, 2 plus 3, which is going to be 5. So the whole of AC in this case, if we are to relate to this statement, it means the whole of AC is equal to 5 parts. It carries 5 parts of the line, but AX carrying 2 parts. So meaning to say AX is going to be 2 out of 5 parts of AC in this case. What does it mean about XC? It means XC is going to be 3 parts out of 5 of AC. Take note the direction also here. I'm indicating also the direction from A to C. We are referring A to C. If you want to refer C to A like this, it means you are going to refer CX, not XC, but CX. So you're going to be talking about CX being equal to 3 over 5 of CA, the direction from C to A. That is the same way that you are taking. The same thing from X to A. Take note the direction X to A. We are going this way from X to A. So we are going to have this as XA is equal to 2 over 5 of, we moved it from X to A this way. So we are going to move from C to A. That is the direction. So it is going to be 2 over 5 of CA in this case. All right. So take note how you relate the direction. When you are dealing with the vector, it's all about direction. It's not, if it was just a line you are considering, a normal line, there is no need of us talking about the direction, but because we are dealing with a vector, that's why I am emphasizing on the direction. If you don't understand the direction of a vector, guys, it's useless for us to attempt these typical questions because it's all about the direction and also the application of these ratios. All right, so this is the first thing that you need to just understand before you attempt your questions. Now let's see the first part of our question, item 1. We are given express in terms of P and O, meaning to say our answer can carry P and Q, or it can just be P only or Q only. All right, does not matter this one. All right, so let us have the first one, AC. So we need a route that we are going to take from A to C. That we are going to consider in this case. So you need to take from your diagram the direction from A to C. So considering from A to C, from our diagram here, we can see that this is the part that we actually need from A to C. But you are going to consider now the way that you are going to take from A to C. It's all about the route that you are supposed to maintain. So in this case, let me say I choose, because here there are 2 ways, because our diagram is complete everywhere. So we can choose to move A to O, then from O to C, that is from A to O, then O to C in this case. All right, which is from A to O, we are opposing the direction, so that will be minus 4P. All right, we are opposing the direction, it's this way, but as we are going this way, so that will be a negative. Okay, then plus OC, from O to C, we are maintaining the direction of the arrow, so meaning to say it is going to remain as a positive, so that will be plus 5Q, of which someone could have taken the direction from A to B, then from B to C. It was going to be one and the same thing. Let's try to have it here. We want to calculate AC, so we can choose from A to B to use this way. So we're going to have A to B, then we move from B to C. All right, so that will be plus BC in this case. All right, so if you consider this, it is going to be the whole of AB, and we are maintaining the direction because our arrow is going to B. So that will be a positive 5Q. Then from B to C, we are opposing, we are going this way, we are opposing the direction of the arrow. So that will be a negative 4P in this case. All right, so that is, as you can see, it's one and the same thing. Negative 4P, here we've got negative 4P, plus 5Q, here we've got plus 5Q. So that was the expression for AC. Let us check the other part now. We are given to express OX in its simplest form, OX. So if you are to check now, on our diagram, this is what we need. We need to move from O to X. That means from O here to point X. This is the one that we want. So it was going to be 2 ways that we're going to consider. It's either we're going to have this as from O to A, then from A to X. Remember, I explained about AX before, how you find AX. Or you're going to move from O to C, then C to X. If you use CX, therefore, I talked also about CX, meaning to say you have to find the vector CA. not AC. You simply multiply that one by what? By a negative to find the CA. So not for you to confuse finding CA, this and that. Maintain what you calculated before. And what is it that you calculated before? It's vector AC, this one. So we have to maintain the AC part. Remember, I said on vectors, direction is important. So which part carries AC? That is this one. So we are going to choose the one that consists of AX, because it is the one that goes with what? AC. So our direction for OX, we are going to choose O to A, then A to X. All right, so let me just have it here. This is number 2. So our number 2, we said OX, we are going to move from O to A. Agreed, that's going to be OA plus A to X in this case from our diagram. All right, O to A, then A to X. Are we having OA? We have OA, that is, we are maintaining our direction. So that's 4P. So this one is going to be 4P. But before you substitute, you can replace first AX, because we said AX is equal to this. So we can replace that first before we substitute. So that will be plus 2/5 of AC. All right, meaning to say now we can substitute our values, because we calculated everything. We calculated AC before, and OA is there on our diagram. We said from O to A, it's vector 4P. So we are going to use vector 4P there. All right, so this is going to be 4P plus 2/5 of AC. So the 2/5 multiplies the whole of AC, and this is our AC that we calculated here, which is the same as this one. So that's minus 4 vector P plus 5 vector Q. So as you can see, they are like terms. We've got vector P, vector P. So we need to expand the brackets so that we can collect the like terms together. So you multiply here, use your calculator. 2/5 times -4 is going to give you -8/5. So there you just simply need a calculator in order for you to attempt this, or let me just have it on the calculator. To simply multiply direct like this, 2/5, so it's going to be 2/5 like this times -4. So you multiply -4, so that will be -8/5. Vectors, you are allowed to work with improper fractions. So write it as an improper fraction, it's fine. All right, then you do the same. 2/5 times 5, which is on Q. So it's going to be 2/5 this time times a 5. So if you multiply to a 5, that will be a positive 2. So we are going to obtain 2Q in this case. All right, collecting like terms, we've got P and P here. So you can subtract 4 minus 8/5. This is paper 2. Use your calculator, subtract 4 minus 8/5. So we are going to subtract 8/5 like this. We obtain 12/5. So that will be a positive 12/5 vector P plus 2 vector Q like this. All right, so this is the whole part that we needed in this case for vector OX. At the end, this is what you are going to obtain for vector OX. So like I said, you can choose to use this direction. So I want you to prove that if you are going to choose your OX taking this direction from O to C, then CX, meaning to say you're going to have your OX as OC plus CX. So I want you to prove and see if you're going to obtain the same answer, and let us discuss on our WhatsApp group for the answer that you're going to obtain. All right, now let us check the item 2 of the question that we are given. It is point Y is such that we have got a condition which is representing point Y on AB. So there's a point Y on AB. All right, so they are saying this one, or that we see on AB, this one, the point Y. All right, so it is such that AY over AB is equal to K, where K is a constant. Express OY in terms of P, Q, and K. Express OY in, take note of the question and what you're given. Okay, so let me start by writing the ratio first so that we can understand this one. I'm gonna have it here. So I want to work it where exactly we see the OY, and we see the OY, the AY on this part. That is the one that we have. So I want us to work where we can properly see on our diagram here. So that is gonna be item 2. So that was our item 2. So the first thing that we're given there was a ratio, AY over AB is equal to K, and you are told that K is a constant. And the question is asking us in this case to determine or to find the vector OI from this thing that we are given here, this ratio. What does it mean? A ratio can be written as a fraction, as we know. So meaning to say here, they are just playing around with us to say, if you were to cross multiply here, you can properly see the relationship between AY and AB. If you cross multiply here, 1 times AY, it means AY in this case is going to be K times AB, which is KAB like this. So the relationship that goes between AY and AB, which is this one from A to Y and from A to B, it is that we are going to multiply by the constant K on AB, meaning to say we can find the vector AY, this one, before we talk about the vector OY, the one that we are asked here. AY is going to be K times vector AB, and we have vector AB, which is from A to B, we said it's 5Q. So that is going to be 5Q. So if you multiply, we are going to obtain 5KQ in this case. That is our vector AY. But this is not our question. Our question is to find OY given this statement, meaning to say it's a continuation from the AY that you calculated. If you are to find OY and your answer or the expression or the root for OY does not consist of AY, this one, it means you are wrong, because that is the only part that is carrying K. So meaning to say you need to find a root back on your diagram, the one that you're going to use, but this root must contain AY. Okay, so which root are we going to take from O to Y, which is this one? But this root must contain AY. AY is supposed to be there. It's supposed to be part of our root, this AY, which is the one that we have here. So meaning to say we are going to move this way. We want to move from O to Y like this. All right. But AY is considered. So it is going to be OA plus AY. AY is now there. We want this to be part of our root. So we said at the end, this is going to be, let me write it so that we can fill in. So it is going to be OA plus AY like this. All right, whereby we have the value or the expression for OA from O to A, it's 4P. So this is going to be 4P plus AY from A to Y. We don't have it on the diagram, but we have it from this statement that we formulated from this ratio. So AY is equal to 5K times vector Q like this. All right, so that is what our question was all about. So this one, it wanted you to actually understand the concept of a ratio, properly understand the concept of your ratio. So let's move on to the other item. The other item of our question was now item 3, and item 3, we have a statement again, given that the same OY that we had here, now it is equal to H or X, where H is a constant. So it can be written in terms of another constant, and they want us to express OY in terms of P, Q, and H. So we are given OY first is equal to, that is where we have to start from. All right, so this one is direct because already we calculated OX before. If you check here, we calculated OX. So I'm gonna have it here. I'm just going to write it here. So this is our item 3. So we are given that the first thing, OY is equal to HAX, HOX. So this is what we were given. And they want us to find OY in terms of, already we calculated OX here. So this one, there was nothing, it was just substituting. So it's H times OX. What was the value for our vector OX? All right, so this is our vector OX here, which is 12 over 5 vector P plus 2Q. So this one, it was direct. You just multiply everything by H. If you multiply, we are going to obtain 12 over 5 HP. If you multiply by H here, we are going to obtain 2HQ. All right, so we have vector OY in terms of P, Q, and also H, which is our constant. Then after this one, our question now was using the results in item 2 and 3 find the value of h and the value of k. All right, so now you need to find the value of h and k from these items that we got. Item 2 and item 3. Remember, item 2 was to calculate vector OI. Item 3 also was to calculate vector OI. And I said whenever you are to calculate the values of unknown, what you need is to work with the two given vectors which are the same. So these are the two vectors that you need to work with, OI and OI. So I'm going to write this separately. So item 4, I'm just going to have it here separately. So remember the first vector that we had for OI, this one that we had in terms of K, it was 4P plus, we take this one as it is. So it was 4P plus 5KQ. All right, so this was 4P plus 5KQ like this. All right, you write the second vector, OI, the one that we got now. Remember, this one in terms of H, we want this one, which was in terms of H, this one, which is 12 HP plus 2HQ. So this is the one that we are going to take. All right, so we write it aside. So we got 12H, that was 12 over 5 HP plus 2HQ like this. All right, so these are the two vectors that you have which are the same, vector OI and vector OI. So how do you formulate equations? You simply need to equate the same vectors. All right, so you have to equate the same vectors in this case. What am I trying to say? We have got vector P and vector P. In actual sense, we're supposed to equate them together to say 4P is equal to 12 over 5 HP like this. These are the vectors which are equal. So they must be equal in terms of their presentation. So if we are to check here, we can see that, all right, here I've got vector P and vector P. So at the end, I'm going to remain with the 4, which is equal to 12 over 5 vector P, 12 over 5 times H, which was the same thing that I was explaining from other videos to say, you simply equate these constants, the ones that are multiplying your vectors. So you simply say 4 is equal to this. But in actual sense, we are equating the vectors as it is. Where there's a Q here, you are going to equate as it is, which is 5, it's a positive. So it's a 5KQ is equal to, where there's a Q on the other side, 2HQ. But as we can see, these two are the same, so you cancel them. So meaning to say, you remain with the 5K is equal to 2H, which is the same thing here. 5K is equal to 2H. Now you've got two equations that you have to consider to be solved in this case. This equation and this one. So depending with the way that you're going to solve, it's no longer about a vector, it's your understanding now on how to solve equations. Like here, if we check, we only have one unknown. So we can solve for H. Here we can simply cross multiply and solve for H. If we cross multiply here, 5 times 4, we are going to obtain 20, which is equal to 1 times 12H, which is 12H. Divide by 12 both sides so that you remain with H. So it is going to be 20 over 12, which is 5 over 3. If we reduce this one by 4, that will be 5 by 4, 3. All right. So with the value of H that we have obtained here, we can simply substitute it now on this equation. Because here we've got H, so we can substitute here the value of H that we got to find K. So meaning to say, we are going to have 5K is equal to 2 times the value of H that we got on this part, which is 5 over 3. So we are going to obtain 5K is equal to multiply. Remember, this is paper 2. You can use your calculator, or this is same as over 1. So you can multiply 2 times 5, which is 10 over 3. So you can cross multiply because this is same as over 1, so that we can remove the fractions. So 3 by 5 is going to give us 15K is equal to 1 by 10, which is a 10. So to find K, simply divide by 15 both sides. So by dividing by 15, we are obtaining the exact value of K. By 5 here, that's 2. By 5, that's 3. So we're going to obtain 2 over 3 at the end. All right, so this is the value of K that we needed in this case. So like I was saying, all we need is to know the concept of vectors. If you are talking about equal vectors, know the concept, what is happening between two vectors which are equal. It means the corresponding values where there is vector P are the same, where there is vector Q are the same. So you form equations from there. Once you have formed equations, how to solve, it's up to you. You check how the equations are given. If we have got an unknown, two unknown values here, and also two unknown values here, that is where we can think of using elimination method, whatever method that you can think of, as long that method is for solving simultaneous equations. But here we took advantage to say already there is only one unknown here. There is only one unknown. So we can use that as an advantage to calculate for H. Whatever value that you obtain here, substitute on the other equation so that you can find the remaining unknown value. So that is the concept when dealing with vectors.